Hi, this is Devin Odell, and this is my final presentation for the IoT class. And for my project, I decided to make a garage door opener using the microcontroller. And not only that, but it was to create as many interfaces as I could for interaction, especially for convenience. Now, it is important to note before I go too much further that with convenience comes a lot of security risks, and especially in this situation, I am using a Google Home to open my garage door, which means if anybody tries to do something like this, be really careful where your Google Home is. So for me, on a day that I have my windows open, you can actually see I have it right there. I have one there and I have another one in my house. And if I were to leave, you could actually say it through the window. Request that Google open the garage and it would actually work. So just be really careful of where you're putting it. So that was my first warning. I will also say the web server that I used, we used a 3-second delay because it's just a GoDaddy web server. It's not really too robust, and I have quite a few things on there. So I did a 3-second delay, so sometimes the speed of it is going to vary depending on when you caught that delay. If you catch it at the very beginning, it's going to be later. If you catch it at the end of the delay, it might be almost instant. So saying that, as you can see here, we kind of have a rough outline of what the completed project looks like. Unfortunately, Fritzing didn't have the exact board. Even though it says it's the exact board, the pins weren't correct, but the setup is basically the same. We have the relay, we have the ultrasonic sensor. I used a diode and a resistor to work with the relay and to get that all working. So next, the schematic was a little bit more, even though it was the same board, the schematic actually had the right pins. So you can see I used digital pin 2. That was for my relay, for my digital in. Then I had 5 volt power going to both the relay and the trigger, and 2 digital pins for the trigger. But this isn't really the whole point, so I'm going to get right to what the device will look like. So I found, I think it was 1.5 inches, maybe 1 inch deep receptacle from Home Depot that I wanted to package it all in. I couldn't find my drill at the time, so I just kind of used some putty to stick the ultrasonic sensor on the outside. And then on the inside, you can see we've got the ESP8266 packaged away with the relay. And you can see it a lot better here. We've got the shared power. This is our 5 volt. I wanted to keep it as compact as possible, so I used a mini breadboard, and they're both using that 5 volt power. Our ground right here, we've got that's the trigger, pin 14. Pin 2 has that diode's going here, then the resistor is continuing that, and then here is the digital out right there. So that gets that signal when to flip that relay. And right here, this is also really important. You'll see this a little bit later on. These are the 2 wires that actually control the garage door. Here, I would like to briefly kind of cover the code. So the code that I use, you can see here I have several of the libraries. I tried to comment it pretty well so that people would be able to, if they wanted to use this, would be able to without too many issues. We have multiple libraries that are needed. Here we have ones for Wi-Fi and for the HTTP client to operate correctly. The SR04, that is our ultrasonic sensor, which are the pins are defined right here at 14 and 16, and it's actually initialized here. So we have our serial communications beginning pin mode. We are setting pin 2 as an output, which is actually used for the relay, and setting it to high by default. Right here we just have a nice little countdown that's for serial communications, which I no longer use, but I used while I was trying to get it all set up. I did change quite a bit of the text in here, only ones that would be specific to you, such as SSID and password. I took mine out. You would put yours in there. Another example is whenever you see right here, you'll see open and close URL. Those are actually the specific URLs of the web server. So I'll just show you an example of one side of this because it is an if-else statement. So we have, this is the case of my ultrasonic sensor. If the distance is greater than or less than 35, we'll know the garage door is closed. Well, if it is closed, then we're going to use the HTTP request, which we have HTTP client, right? Because if we have a Wi-Fi connection, as long as we have a Wi-Fi connection, then we can run this since we're already in that if command. Then we can use http.begin, and right here you would have that URL, and it's actually used to pass the URL and to make that GET request. So once it gets that GET request, which in my case would actually trigger the relay using webhooks, and then we have this is just to make sure if the value is greater than 0, we can get and print the request. So something came back, there was a payload, and it's important to use http.end at the end to make sure that that TCP connection is closed. So then this is the opposite. If it's not smaller than 35, then it's greater than 35, and then we'll run this code here. That is specifically for geolocation. It's not used anywhere else. So the rest of it is kind of similar. We're using those same HTTP client, HTTP. So it's making HTTP the variable that holds HTTP client. We have begin again, which is just, this is a different URL used for just engage. So if it's closed, it will open. If it's open, it will close. And then finally, we actually have the code that flips the relay, which for my case, I had to open it quickly, which set to low, delay 100, and then close it back because it can't remain open, as I mentioned previously. I do have a couple serial print lines just so I could see which parts of the code are being ran, especially when using webhooks. This is really important when using if and webhooks, so you can see if it's getting through your if statements or not, because at first it wasn't always flipping the relay, but it was actually getting into the if statement, so that's important to use that. Here we just have a little error message if there is no connection. So that's our else. That's else to everything. And either way, at the very end of it is going to end that HTTP connection again, shutting down that TCP. So I'll go ahead and introduce the actual demonstration of the device.
So I'll apologize beforehand. The lighting is going to get really bad because in the garage we just have an LED bulb up here. I do have a Google Home Mini out in the garage. Up top, hopefully you'll see, especially once the garage door is closed, we've got the device. We've got a nice long cable connecting it to power. They're just using an Apple little inverter. I've got the device in a little box with the relay, the ultrasonic sensor, which is sensing the door. And so let's go ahead and test it out. Hey Google, close the garage door. There it goes. There it is right there. Hopefully we'll hear the relay click this time. Hey Google, open the garage door. So just before it, you can kind of hear the relay clicking, connecting those two wires. You have the black wire, which is my power, and right above that are the two wires that are connected with the relay. Those two wires connect right there. And when they're shorted out, when they're grounded, they'll make that connection and open the garage door.
That was a really cool example of implementing that first interface that I wanted to accomplish. And so I will kind of briefly discuss how that's accomplished. Using, as my proposal determined, using IFT, which is IFTTT, in combination with Maker, which is no longer Maker, it's actually webhooks now, you're able to send a GET request with another request. So for example, if this then that, it's basically just an if statement that says, if I say this exact statement to my Google Home, then it will get this web request from my web server. So for this, I actually had to set up, I do have a website, I have a domain and a web server for a different purpose. So I was able to reuse that, which I'm not going to share on here for security purposes. But I was able to use that as a web server to host the commands that I needed. And then webhooks is able to, once the commands are met, is able to go out and actually get that web request, which is amazing. So you can do all kinds of things with that. Actually, all of my interfaces hinged on the combination of those two, along with obviously the code that we ran. So it goes in, it gets that web request, and then it runs the code, which in this case, because of the garage door, it had to when it would set to low, it would actually connect, and I would have to delay 100 and quickly close it again, because if you leave it open, you won't be able to open the garage door with anything else. It'll just stay connected the entire time, and the garage door doesn't work by just open, close. It has to be open quickly and closed. So now we're going to go to another video showing another one of the interfaces.
So I did want to show one more pretty cool interface, because as I said, my project's point was to have multiple interfaces to make it as convenient as possible. So in this case, we're using IFT and Maker to have a widget on even iPhone, so it's not exclusively Android. So I'll show you here. You can see I have access to Google Assistant here, and then I have my widgets, which you can just simply go to. And if I press make a web request, which is webhooks, you see it load, and the garage door will open. And I can actually stop it, and I can close it again if I hit it one more time. Okay, and while I'm at it, I will show you the other interface. I can show you the voice from here, actually. It's the same assistant as the Google Home and Google Home Mini. Hey Google, open the garage door.
Okay, opening the garage door.
Okay, and so I'm going to go ahead and show that functionality of that third interface, which is complete automation. And so for me and my motorcycle, this is a great feature that I have, because when I enter that geolocation, it will automatically open the garage door. But that ultrasonic sensor is needed to see the current state of the garage door. So if it's already open, it won't try to reopen, which would actually close it. It will be able to find the state, so if it is open, the ultrasonic sensor would see it and not send the request. However, if it's closed, the ultrasonic sensor won't see it, and it will make that request, that web request, which will actually open up the door, which you're going to see here in a minute. I kind of had to crudely do this, so I apologize for the video. The quality is not great, but it does get the point across that when I pull into the driveway, it takes a minute again because of the delay and because we're using a third party to do all this, so it's going through quite a bit. And as you can see, here we go. It opens. So there we have it, another really cool interface. Now the other great thing is there are so many things you can do with this. You can have this as a tablet widget that maybe you have on your wall all the time. You could set it to when you leave, which I will do this, when you leave the premises, to make sure the door is closed, maybe send you notifications at certain times if the door isn't closed. Another one that I really want to implement, which will be easy, just another line of code, would be when you enter the geolocation, it opens the garage, and then maybe after a 15-second delay, close the garage again. So that way you're not even touching anything. I would literally be putting the motorcycle away, stepping out of it, and the garage would close itself. So thank you guys so much for watching. Hopefully you enjoyed the video. I did put a lot of work into it, but it was a lot of fun, so it barely even felt like work. Really enjoyed the project, and I hope you guys did too. Thank you so much for watching.